You might have heard that having healthy mitochondria and having an abundance of mitochondria helps you to burn more fat. And this is why a lot of people will, for example, do things like getting in the ice cold in order to actually have more mitochondria and essentially burn more body fat. But why is this the case? And in order to understand this, we need to understand how the mitochondria works when it comes to fuel breakdown, what we're actually using in the mitochondria to make energy, to understand how we actually create more so that we can effectively burn more body fat. So when we're taking down what we have stored on our body and breaking it down to make energy, where we do this in the cell will be dependent on what fuel we're actually breaking down. For example, we can actually break down fuels within just the cytosol of the cell, and then we can break down fuels within the mitochondria. Now, what's really interesting to understand is that glucose, or the stored form of glucose, glycogen, can actually be broken down in the cytosol of the cell. It doesn't even need to go into the mitochondria. And this will happen when we don't have enough oxygen available. This is why glucose is always the primary fuel source when we need to do something quick. But it's not until we actually have enough oxygen available that we're actually able to break down other fuel substrates like fat or fatty acids that we've taken from our fat tissue, and we're going to shove them into the mitochondria so we can, break them down to make energy. But as I said, the difference here is the amount of oxygen available. And this is why people will often say, if you do slower, steady state activity, we actually will burn more body fat. And that's actually correct, because essentially you are working at a pace that your body is able to keep up with the oxygen demands. If you're working harder than that, and your body isn't able to keep up with the requirements of oxygen, then you start going back into burning glucose. So like anything in the body, when there is a demand for it, the body will supply. So essentially, if you create a situation in which your body goes, I need more of this because we need to go through this process more, I need to be able to cope with this, it will create more of whatever it is that organelle is. So for example, if we are going through a process where we are breaking down fuel substrates that do require oxygen, and because we need mitochondria to be able to do this, the body will go, I better start making more mitochondria. So just to reiterate here, while we can convert glucose into acetyl-CoA and push it through the mitochondria to make energy, it's not essential. We can actually take that glucose and convert it to something called lactic acid and make energy via that way. But when it comes to burning fat and fatty acids that we take from our fat stores, that does require mitochondria and oxygen. So essentially, the more of the activity that you're doing that is burning fat, the more mitochondria you need, and therefore the more the body will have to go, I need more mitochondria to be able to do this process. So working within a point that is allowing your body to utilize oxygen to break down the fat will make your body respond by making more mitochondria. So essentially, by working up to the threshold of when your body starts producing lactic acid, or that burn sensation, this will start to stimulate the body to get better at working within that capacity. So essentially, what do I mean? By working to a point where you're able to bring in enough oxygen, but you're not quite getting to that point where you can't work anymore because your lactic acid is building up, is the prime amount of activity that is going to stimulate the production of more mitochondria. Other thing to consider here is that the more the body's requirement for oxygen increases, our body will also respond in making more of the things that are going to circulate that oxygen so that we can supply it to our mitochondria. What does this? Our red blood cells. So anything that is going to tell the body that we need to make more red blood cells so that we can deliver this oxygen to the mitochondria and use the substrates to make energy. So for example, if you do high altitude training, this is going to stimulate the production of something called EPO, which is going to make us increase our red blood cell production and therefore circulate around more oxygen. Other things to consider here are, in order to make really healthy red blood cells that can supply that oxygen, we require a couple of really important things. We require iron, because it's part of the heme component of the red blood cells, and we also require B12 and folate. These are going to help us to essentially mature our red blood cells and allow them to condense and form the right shape. So it's important that we're getting enough of this from our diet and obviously also able to absorb it. Remember how I talked about cold therapy and how that helps to actually also build more mitochondria? How does this happen? Well, essentially when we are exposed to the cold, we start inserting these special proteins into our mitochondrial membranes, and essentially this disrupts ATP production. And so this makes our body respond by going, we need to push more fuel substrates that we have stored in our body or that we're eating and push that through the mitochondria to keep supplying energy. This is actually going to make us make more mitochondria because essentially the body is responding by going, we need more fuel substrates. The thing that can allow this to happen is mitochondria, and this will produce more energy. So cold therapy does also help you to produce more mitochondria.